All right, so in this video, we're going to be looking at how to do synthetic division. Now, synthetic division is generally restricted to dividing by factors of the form x minus c, where c is a constant. Now, if you are dividing by a factor like 2x minus 1, you can rewrite this as 2 times x minus 1/2. And then actually do the synthetic division with the 1/2 in the process, and then come back and take care of the 2 later. But you can't actually divide by even a linear factor like this. It strictly has to be, for this process to work, a linear, no coefficient x and a single constant afterwards. Now, the general idea is we're going to basically just be working with the coefficients. And so anything more complicated than just x minus a constant, you should use regular long division processes. So let's look at an example. Let's say I want to divide the polynomial x to the 4th minus 3x squared plus 2x minus 1 by x minus 2. Now, I know for the start that because this is a 1, this isn't going to divide evenly, and that's fine. Now, I'm going to draw this because it's just going to be easier than typing it. And I'm going to put out a drawing canvas to kind of keep this contained. So the general idea here is you're going to write down your coefficients for your polynomial underneath your pseudo division bar. And so the coefficient for x to the 4th is 1. There's no x cubed in here, but you have to fill it in. So that's a 0 for the x cubed. We've got -3 for the squared term, 2 for the linear term, and then -1 for the constant. And when you are doing synthetic division, this guy right here is equal to c. Not the minus sign doesn't go with it. Okay, so this would be a 2. So whatever it is you're dividing by in your factor, you have to flip the sign. So if this was x plus 2, we would have to treat it as x minus a -2, and then we would put a minus here. But because this is x minus 2, the form that we're looking at is x minus c, and it's c that goes here. So this is 2 that goes here. Then we're going to leave ourselves a little bit of space, and the first coefficient is just going to simply drop down. And that's because when we divide by x as the leading term into this x, the coefficient of whatever it is, it stays the same. So then we're going to multiply 1 and 2. This, whatever this coefficient is by this, we're going to multiply it, and we're going to put it here, and then we're going to add. Now, why are we adding? Well, this was a minus sign. I changed the sign. And then if I'm doing long division, I'm also subtracting. So if I'm thinking about this in terms of the relationship to long division, I brought this down. I multiplied the resulting x's by my x minus 2. The next coefficient became -2 times whatever. And then I subtracted, and so I flipped the sign. So again, I'm adding, and I'm going to get a 2 here. And then again, I'm going to multiply, and then I'm going to add. It's going to give me a 1. And then I'm going to multiply, and I'm going to add, and then I'm going to multiply, and I'm going to add. Now, this last component down here, this is the remainder. And these other coefficients, these other numbers, they're going to be the coefficients of the polynomial that resulted from my division. And again, because I'm only dividing by a linear term, the result of my division is going to be 1 degree less than it was before. So the result is going to be x cubed plus 2x squared plus x plus 4, and then 7 over x minus 2. So again, that's my remainder. So always this is going to be 1 degree less than what you started with. And then these will be the corresponding coefficients as you go down your polynomial. So since I started with x to the 4th, the result of my division is x cubed.